Second problem, B2, is called cow splits. And for me, when I read all the three problems, it is what I left for the last because it seemed most scary to me. I don't know. We have a string given, which is concatenation of the word cow, possibly rotated, or it's a cyclic shift of it. So we have cow, auk, and uko available. This, and that. And we add it, we concatenate it and glue together. Like maybe after this we have another occurrence, maybe then this one, and so on. We are given such a string. Then we choose a subsequence. And as I told you at the beginning today, some problems in bronze today were very difficult to understand, even to read. That's some, I think, bad quality of this bronze contest. So you remove a subsequence. So you choose a subsequence. Let me mark something. Yeah, maybe you choose this character, this one, and this one, and this is your subsequence, CWWO. This one actually wouldn't be legal because it needs to be a square string. Square string is defined a moment earlier in this paragraph. It says that it needs to be some string repeated. For example, this subsequence that I marked here is not good. So it needs to be instead something like CW and then again CW. This is good subsequence that we can erase. So in one operation, we can erase this, and that. Always, of course, even number of characters. We need to transform S into empty string. So we need to keep removing some subsequence until the string is empty. And we need to output what is optimal way to do it, so minimum number of operations. And there is this extra complicated thing which says that in some tests, you don't need to be optimal. You can do one extra operation. That's, I would say, unusual, but in Olympiads often you will get partial points based on exactly the number of operations used. So maybe more common would be that if it's optimal to use 7 operations and you instead used maybe, I don't know, 12 operations, then we take the ratio 7/12, and this is the ratio of points that you get. 7 out of 12 is equal that much, so 58% of points you would get for such test. This is maybe more common, but here it's just this binary thing of in some tests you need to be optimal, in some almost optimal. And it was maybe unusual that K was up to 1. That part was suspicious, and you can even take some guesses of what is optimal from this. Sometimes subtask is also a hint towards a full problem. And then there were examples. A very experienced participant from such subtask and from those examples would already take a guess. And for me, this was my first guess, but I understand that for beginners, it's hard to get this kind of intuition. My first guess, without any reason, without any understanding of samples and so on, is that the answer will be at most 3 operations. Even stronger guess is correct, but this was my guess based on what I saw in sample outputs, that we never here see values bigger than that. And also based on the fact that this is bronze division, where the problems are not supposed to be very difficult. So maybe some very simple construction, very simple operations are always possible. Another thing that suggested this to me is that in some way, the problem must be simpler if we are allowed 1 extra operation. Usually when, for example, it's some kind of, I don't know, DP problem. If it's dynamic programming and you're computing that the number of operations required is 70, is it that different to achieve something in 70 versus 71 moves? Usually not. But it does make a huge difference whether you do something in 2 or 3 moves. So from both of those, strong, experienced participants would immediately get this guess. And for not that experienced participants, you just need to work more on the tests before you realize that. Now, without even guessing, if we start thinking about it, we will realize the following. The easiest possible square strings are just something that consists of a single character, like this. This is a good string that you can erase. So if there is here, let me maybe make, I will take this. I will make it bigger. Sorry about the quality. What I can do is I can take www and I can erase it. That's one operation. Then I can take all the occurrences of C. I can erase it. And finally take all occurrences of O and also erase it. So even without, it turned out that my guess, my intuition wasn't that useful because in a minute or few minutes, you can get this simplest possible strategy. So achieving 3 operations is trivial. You just erase all occurrences of a single character at a time. This is sometimes impossible. You will even in samples see that the answer might be -1. And that's, it's clear to see it once you analyze, for example, this thing. You cannot erase 3 occurrences of W because it's not a square string. A square string needs to be string then repeated. So it needs to be even. The parity needs to be divisible by 2. You cannot erase 3 occurrences of W. And generally, if n is odd, then the answer is -1. If n is even, then also the full length 3 times n is even, and then we can achieve 3 operations. Okay, but maybe 1 operation is possible, or 2 operations are possible, or 3 operations. We know that this is possible. So that part is done. We need to figure out if 1 is possible and 2 is possible. 1 turns out also very simple. 1 operation means that at the same time we erase everything. For that, we just need to check if we can erase everything, that is, first half of the given string is equal to the second half of the given string. You can achieve that by using for loop or substring operation. Loop or substring. Whether you use C++ or Python, in both substring function exists, where you check if first half of indices is equal to the second half, or use a for loop for that. If so, then we know that 1 operation is possible. And the only missing part is if 2 operations are possible. That will be the hardest part of the task. But if we can make a mistake by 1, so if k is equal to 1 in the input, which means that we can make a mistake by 1, if it's possible to do 2 operations, we still can do 3. So the following pseudocode is good for k equals 1 pseudocode. If string of 0 to half is equal to string from half to the end, then print 1. And else, print 3. It's more Python than pseudocode, this thing. Else print 3. And we need to also output the operations that we're doing. It's said that for every character or every index, we need to output in which operation it is being printed, which is non-trivial here. But what we need to do here is for every index, for every character, we need to output when we erase it. And we can, for example, say that C we erase first, then O, then W, which means that if we see character C, we output 1. If O, then we output 2. If W, we output 3. And well, here we just output 1 all the time. N times print 1. That's the pseudocode solving that subtask mentioned at the bottom of the problem. The subtask worth not maybe many points. It was just 2 tests out of 14. So like more than 10% of the points for this problem. Well, still something. And we have some missing part. Back to the strategy of Olympiad competitions is that unlike code forces or ICPC, implementing subtasks or brute forces, some slower solutions, is extra beneficial in Olympiads because you get feedback and you will get information if so far your solution is correct. So if you suspect that this is anywhere part of the intended solution and just one extra part is missing, then you need to implement it anyway in the full intended solution. So it's not a waste of time to implement it and submit just this part, get confirmation that some tests are passing, and you can safely assume, no, this is correct, I need to focus on the missing part. Versus if you implement everything at the same time, it's then if you have a bug, it's harder to figure out where it is, the bug. Okay, so what about detecting if two operations are possible? There is one part of the statement that we have not used yet, and I would say that it was the most unusual part. That the string in the input isn't just some arbitrary string, because instead it's concatenation of cows, in particular, so just concatenation of those three things possible. Not even just any permutation of the three characters, just those cyclic shifts. It needs to be special in some way. And if you start experimenting with small tests, maybe, like cow with AUK, let's say, can we achieve two operations on this concatenation? You will realize that, yes, we can. There are a few ways sometimes to do it. But here I can take, let's see, can I erase first the two W's? So can I erase those two? No, because the remaining part, COOC, is not good. It's not, like, Coco would be good, but this is not good. What else can I do? W can be combined with O, because O is earlier. So can I erase that thing? Yes, we can erase OO. This is repeated string. And then the C with C automatically is done. If you experiment with two strings concatenated like that, you will realize that two operations are always possible. So what if I add something? If I here add another maybe oak and then maybe co, just something random. Of course, I cannot achieve the result using three strings because of the parity. N is odd, then there is no solution. What now? Again, I can try. WW didn't work before, but OW worked. OW, OW. There's also OW here, but then it's not present here, so I cannot do anything about it. If I want the first half to be equal to the second half, then maybe I should leave this OW equal to this OW, and then take something from here that is the same in this part. Right? The property of square, just like palindromes, are often about looking in the middle and saying that this part is equal to this part. That's the nature of palindromes. Versus here, we want to say that the beginning is equal to what is just after the half. And the statement doesn't tell us that the half will be exactly in the middle of the initial string. Half needs to be in the middle of our subsequence. But this is the easiest assumption, that it will still be the middle. So if we take here OW, here OW, can we take from here something the same as here? We already said that for two strings it's always possible. In this case, let's say WC, yeah, WC, 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 and then OW, OW. That's it. I highlighted or I underscored in yellow the subsequence that I can take. And it is equal to OWWC, OWWC. This part is repeated, so it's a good squared string. Remaining part, CO, CO. Actually, automatically, if what you take from one string is the same as in the other, and it's two characters, then the third remaining character needs to be also matching. And it turns out that this is always possible. If you have some free characters, so 1 to 3, 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 what you should do, and the full solution is, you imagine the split in the middle, you look at the first three characters and the first three characters after the half. You look at two characters that are the same, in the same order. Like here above we took OW and OW. You say that this is what you take. This will give you some characters. So maybe you're erasing those two and those two. Automatically, the third one missing needs to be the same. So in the second operation that we are doing, we will be good. And then you also compare those three and those three, and so on. Using the input here, let's see. There was here some input. Again, sorry about the quality. It consists of a lot of triples. The splits are here, there, here, here, here. In particular, it's very important that the half is exactly there. And what we are doing in the algorithm is the first three characters we compare with the first three after the half, COW versus OWC. We always can choose two characters that are the same in the same order. Here it's OW and OW. Just for every pair of possible strings, you can figure out what to exactly. And then you do the same for the next pair of triples, cow versus oak. Again, OW is good. Finally, OWC, OWC. Here you could take all three, but I think for safety, let's do the same principle, WC versus WC. This is what I output as my first operation, and the remaining indices are automatically done in the second operation. And that's the full solution, that you need to check if one operation is enough. So if this, maybe let me scroll back here. Oh, I'm here. Okay. So now full solution is that first we check if one operation is possible. So first half equals second half, and else always two operations are possible. So you output 2. And here you make a for loop. Let's say you iterate the first half of the characters for I equals 0, and then you keep jumping by +3. In C++, it would look like this, smaller than half, and I plus equal 3. So this way you iterate the first half using triples, you jump by 3. And here you compare S of I plus 1, S of I plus 2. So this is this triple here. And you also look at S of I plus half, I plus half plus 1, I plus half plus 2. You have this pair of triples, and you now need some ifs to see what two characters are the same in the same order. Maybe, for example, the first character is the same as this one, and then second character is the same as here, third one. If so, for those indices, we output 1, and for others, we output 2. We don't actually output right here. We have some extra helper array. And what we do here is we say then answer of I equals answer of I plus 1 equals answer of I plus half plus equals this equals 1. And other things we mark as 2. It might be scary thinking about those cases. Certainly, we don't want to look at 3 possible strings and then all 9 possible pairings. We don't want to make ifs for. If we quickly look at my code, what was the name? Was it splits? Yes, it was splits. In my code for this part, if n is the length of the full string, then I have this for loop over the first half. I keep jumping by +3. And I do the following. I check if the first character si is equal to which of those other three, and it automatically implies the full comparison because we don't have that many possibilities of the orders. Remember, just cow, oak, and what else? WCO. Those are possible. So if I know that in one triple I have C something something, in the other I have C something something, everything is the same. It's cow cow. If in the first I have cow and in the second I have something C something, I know that those two are equal to those two. So even in my drawings, I told you that there are too many cases. It's not that bad. So I just check which relative shift it is. There are three possibilities. And depending on that, there is another, let's say, pair of indices that I need to say for those operations, I'm doing them in second operation. By default, I created array with only ones inside. I have a vector with n elements equal to 1, saying everything by default I'm doing in the first operation. And then some things I do in second operation. And then the code turns out very simple. If you have any questions, then now is the time. The time complexity here is just linear. We don't have any nested for loops, so it's O of n. And that is the end of the second problem, which is cow splits.